When automotive brands start sourcing jump starters, many assume it's a fairly simple product. At first glance, the structures look straightforward. You have the battery cell, cable, and protection circuits. However, in reality, most sourcing failures do not come from the product itself. They stem from how sourcing decisions are made. Over the years, we have seen brands run into safety issues, certification delays, unstable production batches, or unexpected cost increases several months after launch. Today, I want to walk through several common mistakes we often see when brands source jump starters and explain how these problems can be solved. One situation we see quite often is brands comparing suppliers mainly through quotation sheets. That approach is understandable. However, with products like jump starters, the price difference often reflects deeper technical decisions. For example, battery cell grade, protection circuit design, and how long products go through aging tests. One factory may run a full 48-hour aging test, while another factory shortens the process to reduce costs. Both products may appear to work initially, but long-term reliability can be very different. When we evaluate suppliers, we always go beyond the price. We ask what cell grade is used, how long the testing process lasts, and how the protection system is designed. Battery incidents do not occur every day, but when they happen, the impact can be serious. In jump starters, many risk only appears under extreme conditions rather than during normal lab testing. For instance, we once tested a product that performed well under standard condition. When the same product was tested at -10 degrees Celsius, the output current dropped significantly and the car could not start. In another project, the overcharging protection threshold was slightly too high. That setting gradually increased battery stress over time. Because of the situation like this, we review multiple layers of testing. This usually includes temperature testing, cycle life testing, and verifications of the protection circuits. Another issue that often appears during production is batch inconsistency. Battery cells from different batches may have small differences in capacity or internal resistance. If a supplier switches to a different cell source in one production run, the charging speed or output performance may change slightly. To reduce risk, we usually recommend locking key component suppliers early and testing samples from several production batches before large-scale manufacturing begins. Small trial orders are often used when brands want to test a new market. That strategy can make sense. However, battery products often involve key materials with minimum purchasing thresholds. If the order quantity is too small, the factory still needs to purchase material in larger volume. That situation pushes up the cost. In some projects, we solve this by consolidating several product models into one production run or schedule productions in phases. This approach allows the brand to test the market while keeping the cost structure manageable. Many brands think sourcing is finished once the supplier is selected. In reality, the biggest mistake often appears after mass production begins. Production speed increases, supplier may adjust materials, and new battery cell batches enter the process. If these changes are not monitored continuously, product performance can gradually shift. For this reason, sourcing should be treated as an ongoing management process rather than a one-time decision. Sourcing failures are often not factory problems, they are decision problems. Real competitive advantages do not come from the lowest price, it comes from structure, stability, and risk management. At IF Brand, our role is to help brands identify risk early and build supply chain that can support long-term growth.